Next, we're going to have Danny Blau speaking, who is a design engineer and FTC product line architect at AndyMark. He will be talking about water jetting from AndyMark. So if you want to go ahead and share your screen now.
All right, there we go. Hopefully everybody's seeing my presentation, kind of rocking and rolling. All right, very cool. So thank you for that lovely introduction. It's going to mirror some of my first slide. I started in FIRST way back when in FLL in 2002, and I've sort of stayed with it ever since. And now I have sort of the great joy of working for AndyMark, doing product development. And so if anybody has any sort of really AndyMark related questions, feel free to reach out. You can give me an email just down at the bottom, danny@andymark.com. But for the team here asked me to sort of speak about a really interesting process called water jet cutting. And so this is a manufacturing process that is really, really unique and really has some really interesting benefits and trade-offs. So at a very large scale, what is a water jet cutting machine? So there's kind of a schematic drawing here on the right that shows sort of the actual business end of a water jet, the nozzle end. But basically what it is it's like the world's most ridiculously awesome super soaker. There's a high pressure pump that can, depending on the machine and the setup, can create a water pressure between 50 and 100,000 PSI. For frame of reference, a fire hose is like 1,000 PSI. So this is 50 to 100 times beyond that. And so you get this very high pressure pump, and depending on sort of the setup and the material and the usage case, the machine is typically run with a grit or an aggregate material, that helps give the water a little bit of bite. So this is like, think of just the rough bits from sandpaper without the paper. So it's usually a sand or a ceramic material that goes in there, and so those are the little black dots on that schematic. That helps increase the cutting power of that stream of water. And so the tip velocity, again, this is a thing that it depends on the machine. It depends on sort of what the setup is. And all these parameters can kind of be dialed in for the machine, the setup, the things that you're using. But that tip speed can be upwards of 4 times the speed of sound. That just kind of, again, hopefully paints a little bit of a picture of the scope of what these machines do. And they can really cut through a really wide variety of materials. And so they can cut through materials that are conductive or non-conductive, unlike machines like a plasma cutter that need that flow of electricity in order to make the system work. And one of the other cool things is they don't heat the material like a laser cutter would. So you don't have a localized heat source, because of the way the water cuts, but also because it is submerged in water. And so you have really good heat evacuation as it goes through the process. My little quick tip there. AndyMark does offer some custom water jet cutting solutions. So we have a page on the website where you can upload your own CAD files. And get a quote for those parts. We have a variety of materials. So if you're interested in turning some CAD designs, turning some robot parts from the virtual world into the real world through water jet cutting, feel free to check the website out. So the machines, what do the machines look like? A lot of times the machines will look like a more traditional 3-axis CNC machine. One of the additions to a water jet machine is, as you can kind of see on the picture here, they do have a big tub of water underneath. And so somehow that stream, that 50,000, 100,000 PSI stream of water going 4 times the speed of sound, that has to get contained somehow. And so they have the big tub of water to sort of absorb all of that energy so that you don't cut through the floor of the building that you're in. That'd also be a bit of a bummer. And so one of the things on one of the other additions that these machines will tend to have is a tilt control. So that's an extra 2 axes on the very end of the machine itself, because the jet of water isn't a perfect cylinder. It's more of a cone. And so the jet will sort of flare as it's going through the material. And so in order to kind of combat that, to sort of work against that, the actual tip itself can sort of lean back and forth, and sort of lean by half the amount of that flare. And so the side of the cut that you care about can be nice and straight and vertical, and then the other side will have all of that flare sort of taken up. And so a lot of machines will have sort of a more simple sort of 3-axis plus tilt control. But then there are machines sort of up at the higher end that will take that tilt control to a much higher level, and actually be able to put in, a full, bevel or a much larger angle, purposeful angled cut on whatever material you might be using from. And so these machines, kind of like pictured here, they've typically in the past been large machines. The bed size measured in feet a lot of times. But one of the cool things that started to happen over the last several years is that tech is really starting to shrink. And so now we're starting to see some like refrigerator-sized machines that may have a 2-foot square cutting bed that companies are sort of bringing in as like a prototyping effort. So that tech is really starting to shrink, which is allowing it to go into some new and different places that it hasn't gone. So that's really, really cool. And one of the other benefits that a water jet machine can offer, unlike something like a traditional router or traditional milling machine, is like the actual cutting size can be very, very small, upwards of 0.005 of an inch radius. So if you want to try to go in and make a really tight inside corner on a lot of conventional cutting machines, routers, milling machines, you can't get a really tight, hard 90-degree inside corner. But on a water jet machine, because the blade is so small itself, you can get those really, really nice tight inside corners. And so water jets, they can cut through a really, really wide variety of materials. They can cut through thin materials, thick materials, things that are measured in several inches thick aluminum, inches thick steel. They can cut through granite. They can cut through aluminum, steel, titanium, stainless steel. More or less anything that can be sort of cut with an abrasive, a sandpaper, anything like that. You can cut it with a water jet. And even down to like some really, really small ones. I know there's a scientific agriculture company here in town by us, and so we were over visiting with a water jet supplier, and they were saying that they helped build a machine to slice beans apart so that they could do better splicing, and put those back together and try to get different plant hybrids together. So like these machines can do a whole lot of different stuff, and a lot of that comes down to the skill and the experience of the operators that are using them. They know these machines inside and out, and so they can know what nozzle size to go with, what pressures to run, how much aggregate to send through the machines. The people that run these machines day in and day out, they're the real experts. And so whenever we want to do any sort of water jet cutting as AndyMark, we sort of take those concepts, those ideas, to the experts, say, hey, how do we do this, with your technology, with your machines, and really lean on that expertise. So that's kind of my quick presentation. So if there's any questions, I'm happy to sort of take some of those, and we can kind of keep moving along.
Awesome. Thank you so much. Yeah, we'll just have some people put their questions in.
Sure. Like I said, feel free to check out the AndyMark website. We don't have a super wide variety of materials, but we probably got enough to hit a lot of the key things. We got some thin aluminum, some thicker stuff. We got some steel plate now that people can use. So one of the tricks to the system is that it does take a fairly clean file. So like if you have a drawing with a title block around it, you need to take out the title block and put in just the outline of the part that you want to cut. Exactly what would go into the machine. So that's a tip for those that are maybe, if you get a bounce back error on the website, probably means that you have a few extra lines on the drawing that the machine doesn't quite.
So we do have 2 questions in. So the first question from Phoenix Force is, can you talk about what teams would send to you if they want a part cut?
Oh, sure. So you upload it directly to the website on our water jet cutting page. So it'd be like a DXF file for the part. So if you wanted to make something like, oh, just off the top of my head, a flywheel for this year's game or this year's robot, sending that design for the flywheel and how it interfaces with the rest of the robot. But it'd be the flat DXF file for that specific part, not sort of the full assembly, but just that one specific part.
Awesome. Another question is, how does the water pressure get that high?
Yeah, so it's a lot of there are piston-driven pumps, and so the pump can have we're working through mechanical advantage. So if the pump has a big area and we force that through a really small nozzle, a lot of times the pressure doesn't build until all the way to the very smallest part of the nozzle, as it's shooting out right here, as you can kind of see on the pictures. The rest of the pressure through the line, going from the pump over to these components, won't be quite so high. But as you're trying to squeeze that much through a super tiny little orifice, the pressure jacks way up. So it's, at its foundation, it's a really kind of a simple, just simple machines mechanical advantage kind of a problem, but with sort of the dial cranked all the way up. The pumps that drive these things are like measured in like 50 horsepower, 100 horsepower pumps. They're on the order of small car motors driving these pumps to get the pressure that high.
Awesome. And then our last question is, if someone was like interested in kind of taking a career path similar to you after FIRST, like what did you study and how would you recommend doing that?
Oh, sure. I studied mechanical engineering, and so I have a bachelor's of science there. And working for FIRST product development, working for somebody like an AndyMark or something like that, you really kind of need to be a bit of a generalist. So the experience is one of the biggest things that sort of makes a big impact. So try lots of different things. I say the first easiest part is we offer summer internships. Working directly with our product design engineers, myself and the other people in the team that I work with. And so we bring in interns every year, and they get to do the real thing. They're absolutely there. They're not there getting us coffee and doing the paperwork and the boring things. We have our interns designing parts. A number of the things that we sell now were designed by interns during their time as an intern. So that's one of the exciting kind of pathways to at least get a taste of what's out there.
Awesome. Thank you so much.
Thanks for having me. This has been great.
Yeah.